As I mentioned, one of the other most important applications that we have of exponential functions is in the world of finance. So in particular, in the world of finance, that is on compound interest. So how compound interest works is you have money set aside in some type of account. That money then gets interest added to it. Then that interest gets added to the total bank account. Then that money that you had plus that interest that was added, all of that gains new interest. Then that interest gets added back into the bank, and then all of that, so the interest plus the total amount that you have, all of that gains more interest, and that just keeps going on. So basically, we're compounding that interest, and this works to our benefit, especially when it comes to investments. Now, if you instead have loans, this definitely hurts you. When loans use compound interest, which many of them do, then the interest that is being accrued on your loan, so for instance like student debt loans or mortgages, then that's going to be bad money that then gets added and compounded and keeps adding on more and more. So that's why maybe you know some people who, when they pay off just a minimum balance, then more interest gets tacked on, and then they pay off the minimum balance, but they haven't made any progress throughout the years. So compound interest when you're investing is amazing. Compound interest when you are trying to pay off loans is terrible. So let's see some examples of how we calculate compound interest. So the formula for compound interest is this. So it's going to be a of t. So this is a function in terms of t. So it's no different than, for instance, f of x. You had f in parentheses x. X is going to be this number that you're going to plug in. So we're saying a of t is my function, where t is the variable. Then that means there's a whole lot of letters over here. So I have p times 1 plus r over n raised to the nt. So this a of t, this corresponds to the amount in the account after t years. So say at 5 years later, this would be a of 5. Okay, total amount in the account after t years. P is this initial investment. It's called P because it's also called the principal. So this is how much you initially put into the account. R is going to be the interest rate as a decimal. So usually rates would be some type of percent. So it'd be like, say, 4.7%. Turn that into a decimal. T is the number of years that we're using, and N is going to be the number of times the interest is compounded per year. So remember, we said this compounding process, that money earns interest and that interest gets added in. When that interest gets calculated and added back into the account, that is one compounding time. So you could have things where the interest is going to be compounded annually. So what that means is only once per year is the interest calculated and then added back in. So annually, you would plug in n equals 1 because it's the number of times compounded per year. Semi-annually, this would be n equals 2. Quarterly, if it's done quarterly, well, that would, maybe you'd expect that would be 4. Weekly, then how many weeks in the year is there? There is 52. So if you think about, in general, when n gets larger, so the more often it's being compounded, that probably means that you're going to make more money on an investment, because then the quicker that interest gets added in, then the quicker that amount can then gain more interest. So the longer you have to wait until the interest gets added in and compounded, then the less you make. But these are only going to make small differences. It's not going to make substantial differences. So let's take a look at an example. Suppose you invest $3,000 into an account that pays 8.6% interest compounded daily. How much will it be in the account after all of these different years? Now, if you are maybe money savvy, you might be thinking 8.6%, nothing pays 8.6% these days, right? If you think about bank accounts maybe pay, I don't know, like 0.1% interest or maybe 3% interest. That's terrible returns if you think about savings accounts. So savings accounts will not really gain you any money. But this is much more of an aggressive approach of, say, investing in something like mutual funds in the stock market. Mutual funds are a really good investment strategy, and I recommend that you do this because this type of scenario we're going to do will be fairly realistic, that if you were to set aside $3,000 today, put it into a good quality mutual fund, say like Vanguard or something, we can see roughly how that $3,000 grows throughout your years. So 10 years later, let's think about this formula that we're going to be applying here. So if we take this scenario, we have to find what is P, what is R, what is N, and then what is T. T is going to differ, so let's find the P, the R, and the N. So my function here is going to be A of T. My principal is the amount that I initially invest, which is 3,000. I have 1 plus, my interest rate is 8.6%. Now to turn that into a decimal, I move this over 2 spaces. So I have 0.086. I now divide that by the number of times the interest is compounded per year. So if it's daily, there's 365 days of the year. And then I raise this now to the 365 times t. All right, so this is what we get. Now, again, because if I'm modeling something like the stock market, then we could use this 365 days to give a good idea that the stock market's open during regular business days. So it's kind of close to 365. So if we want to take a look now at 10 years, what we will want to do is we want to plug in 10. So we're going to plug in A of 10 is equal to 3,000 times 1 plus 0.086 divided by 365 raised to the 365 times 10. Now, when you put this into your calculator, you should practice this. So right now, take out your calculator, give this a try typing in the numbers. You have to be careful because you have to use parentheses around the exponent. So when you raise this to the exponent, you'll use the little caret button on your phone or on your calculator, and you want to put the exponent in parentheses. If you don't do that, you'll get wrong answers. So what we find is that this number is going to be $7,088.76. Okay. That's pretty good, right? So your money has already doubled 10 years later. So if you think about if you're 20 years old, when you're 30 years old, that $3,000 investment doubled. It's not bad. It's pretty good. So 30 years down the road. So if we now change this to A of 30, this is going to be 3,000 times 1 plus 0.086 divided by 365 raised to the 365 times 30. So now the only thing that changes again is this t value. This t is changing. So if you type this into your calculator, you should now get $39,579.38. Now that is a pretty good investment, right? So if you are, again, if you're 20, this is going to be when you're 50 years old. This would be a decent amount that $3,000 will now create for you. And again, we're talking about a really aggressive type of investment. This would be something like, again, a stock market where they have historical trends that lead to these types of numbers being realistic. Don't you put $3,000 in a saving account, you will not have this happen. Now, 60 years later, so now we're thinking, okay, this is real long term. So this is going to be when you are roughly 80 years old. Seems like a really long time away. What happens at $3,000? Now, we grew from 7,000 up to 39,000. You're thinking, okay, that's pretty good, right? I mean, it's a pretty decent chunk of time. So, I mean, that's kind of like 5 times the amount of growth. So what would this look like in 60 years? So if we plug in 60 for t, I have 3,000 times 1 plus 0.086 divided by 365 raised to the 365 times 60. This number that we get is now $522,178.90. So you have over $500,000 by just setting aside $3,000 right now. Now, this is exactly how investments work. This is the way that you can become a millionaire without making that much money. I'll be honest, when I retire, I will probably be a millionaire. I do not make much money at all, but this strategy that I started investing money when I was, I think 21 was when I first started investing. That amount of money has been gaining a whole lot of compound interest. So strategically, you should definitely consider this strategy, right? This is the way that people, when they want to be able to have money for the future, they make investments, they use these types of strategies, and then this just allows your money to earn money for you. But mathematically speaking, this is, again, just using exponential functions, right? The base in this case is 1 plus 0.086 divided by 365. You could calculate that if you wanted to. This is that a number that appears in the front, and then we just have our variable that's changing is in the exponent. So if you have any questions on that, do let me know. I'd be happy to talk about finances for days.